Hey guys, I came across this question on Daily Coding Problem. It's a question from a Netflix interview. We have to search for x in a sorted array, but we cannot use multiplication, division, or bit shifts. The O of log n requirements seem to suggest a binary search. This is what a typical binary search looks like, but as you can see, we performed division to get that midpoint. We could have multiplied left plus right with 0.5 instead, or otherwise shift left plus right by one bit. All of them have the same effect, but sadly none of them are allowed. Before we dive into a solution, I'd like you to convince yourself that multiplying a number with 2 is equivalent to adding the number to itself. So just keep that in mind. The very first thing we're going to do is check the first element of the array. We simply check if it is the target number we're looking for. If it is, we return 0. Otherwise, we need only consider the array from index 1 onwards. In a way, we can consider the array to be one index now. Now, what we do is check an offset in the array to see if the number at that offset is greater than the target number we're looking for. And if it is not, we multiply the offset by 2 by adding it with itself. We do this until we reach such an offset, or if the offset goes past the n. For simplicity, let's assume O doesn't exceed the array bounds. It is an edge case that we shall consider later. Let's say the array has n elements. Then the length of the offsets array is O of log n, and this whole operation that we do here is also O of log n. Now let's look at the array again. These are our findings from the operation we did before. We know that the number at offset O by 2 is less than or equal to our target, and the one at O is greater than the target. Therefore, the target number must lie in this interval. Therefore, we must binary search this interval. But now we're back to the same issue that binary search requires division to get the midpoint of the interval. But observe the contents of the offsets array. If L equals O by 2 is length of the interval, then O by 2, O by 4, O by 8, O by 16 translate to L, L by 2, and so on. And this is all we need to perform the binary search, because mid equals left plus half of interval length. And we already know the half of interval length from this offsets array. So now left is the last element of the offsets array, and the right is O. This is how we get the midpoint of the interval. And the rest is just the usual binary search. To address the edge case where O could be past the end of the array, we first adjust right to be length of the array if it is greater than the length of the array, and we add this loop to the bsearch function. Since the length of the offsets array is O of log n, our algorithm is also O of log n. It's a pretty cool problem. I'm guessing it has to do with big data, since there you may have these large arrays which may have large indices as well. So division might be a pretty costly operation, but not addition. And Netflix does do a lot of big data processing. Perhaps that's why they asked this question. Feel free to reach out to me at lifelongcoder007@gmail.com for any questions. Thank you.